Hello, welcome back. For those who might have come to visit or see this video for the very first time, you don't know who I am. I am Sosale Mohana. I'm a maths teacher with a long, almost half a century of experience in teaching A-level maths. And I'm doing these videos just to help students revise what they have learned in school. So let's get on with what we were doing. In the last lesson, I talked to you about the principle of counting, permutation, and I briefly touched on combination. So I'm going back to, of course, I'm going to start today binomial expansions. You are wondering, sir, what has this got to do with permutation, combination, alignments? We'll see a bit later. Let me just write what we did about combination. NCR is n factorial over n minus r factorial, r factorial. A factorial n factorial means 1 times 2 times 3 times 4, etc. times n. I just want to take you through some of the information. What is, for example, 5C1 is 5 factorial over 1 factorial and then 5 minus 1 factorial, correct? Sorry, 5 minus 1 factorial, 1 factorial. What is 5 factorial? 5, 4, 3, 2, 1 divided by 5 minus 1 is 4. What is 4 factorial? 4 times 3 times 2 times 1. They cancel. 5C1 is 5. Suppose I do 20C1. Oh my God. Very good. What is that? Will be 20 factorial over 19 factorial, 1 factorial. What is 20 factorial? 1 times 2 times 3 times 4 times 5 times 20. What is 19 factorial? 1 times 2 times 3 times 4 times 5 times 19. So when you cancel it all, 1, 1 cancel, 2, 2, 3, 3, 4, 4, 5, 5, you're left with the number 20. So I can say 20C1 is 20. So in general, I can say NC1 is n. Very good. What about NC2? To understand this, let's take a simple example. What is the meaning of 6C2? Means you have 6 different things. You pick any 2 of them, 2 at a time, not 1 at a time. 1 at a time would be a permutation. 2 at a time without repeating the selection. Like, the moment you put blue and green, you don't again consider green and blue because green and blue is the same as blue and green because you're picking 2 at a time. So using the formula, it is n factorial over n minus r factorial, r factorial. I don't want to simplify. So 6 times 5 times 4 times 3 times 2 times 1 over, what is 6 minus 2? 4 times 3 times 2 times 1 times 2 factorial is 2 times 1. Now, do you realize I'm looking at a pattern? So I'll cancel that. I'll cancel that. That will be 6 times 5 over 1 times 2. So to find 6C2, start with 6, write 2 numbers, divide by 2 factorial. If it was 7C4, same, 7 factorial over 7 minus 4 is 3 factorial and 4 factorial, which is 7, 6, 5, 4, 3, 2, 1 divided by 3, 2, 1 multiplied by 1, 2, 3, 4. I'll only cancel this because I'm looking at the pattern. So 7C4 will be only 3 cancels. So 7C4 is start with 7, write 4 numbers and divide by 4 factorial. Right? So, in other words, NCR means start with n, write r numbers, divide by r factorial. I want to keep that in mind because I'm going to use that concept a bit later. You know, I being a genius, the only one thing I want to show you is what is 10C4 and what is 10C6. What is 10C4? 10 factorial over 10 minus 4 factorial and then 4 factorial, which is 10 factorial over 6 factorial, 4 factorial. What is 10C6? 10 factorial divided by 10 minus 6 factorial and then 6 factorial, which is 10 factorial over 4 factorial, 6 factorial. What do you notice? This is the same as that. So, what is 10 minus 4? 6. So, if I have 7C5, it's the same as 7C2. If I have 21C9, it is the same as 21C12 because 21 minus 9 is 12. Or NCR is the same as NC n minus R. Keeping those things in mind, I'm going to generate some standard values with n, which I will need later on as well when I do the general binomial theorem or the binomial series. So, NC1, start with n, write one number, divide by 1 factorial. NC2, start with n, write 2 numbers, divide by 2 factorial. What is NC3? Start with n, write 3 numbers, divide by 3 factorial. What is NC4? Start with n, write 4 numbers, divide by 4 factorial. So if I want to find 4C1, 4C3, 4C not beyond 4C4, you can use this concept. And this will come back to you later when we do the general binomial theorem, but for the moment also we require it. So in other words, I can put a small note here. NCR means start with n, write r numbers in descending order, then divide by r factorial. And the other one which I required was NCR equals NCn minus R. You're wondering, look, you have been just going round and round in circles talking about NCR, NC1, and you wasted one whole lesson trying to teach us combination. Yeah, we understand it's a nice way of spending time, but I want to get on with maths. I want to do my A-level this year and not next year. So how are you going to help me? So don't worry, I'm going to start now something which you might be familiar with. You will perhaps understand because you might be familiar with it. What is x plus a power 1? Is x power 1 plus a power 1. What is x plus a power 2? Would be x power 2 plus 2 x power 1 a power 1 plus a power 2. Now, I am a genius. I have done everything mentally. X plus a power 3 is x power 3 plus 3 x power 2 a power 1 plus 3 x power 1 a power 2 plus a power 3. What is x plus a power 4? Is x power 4 plus 4 x power 3 a power 1 plus 6 x power 2 a power 2 plus 4 x power 1 a power 3 plus a power 4. Ah, sir, you have marked it up because you had time to sit and do it. I could write an expansion like this if you want to for x plus a power 15. Only thing is I won't write these numbers. I will use those. Anyway, why am I taking this? Right? Let's see, therefore, if I wanted to find x plus a power 6 and I don't want to multiply. That means you multiply this by x plus a to get x plus a power 5. Then you multiply that to get x plus a power 6. I don't want to do that. Then how would I do it? I look at this. Power 1 starts with 1. Power 2 starts with x power 2. X plus a power 3 starts with power 3. Starts with power 4. So it starts with power 6. Very good. Next. Look at this. X power 1, x power 0. X power 2, x power 1, x power 0. X power 3, x power 2, x power 1, x power 0. X power 4, x power 3, x power 2, x power 1. Monotonous, x power 0. So x power 6, x power 5, x power 4, x power 3, x power 2, x power 1. I don't want to write x power 0. Let me give more space. X power 2, x power 1. Let's look at this. Power 1, those are all power 1s. Power 2, that's power 2. If you have x power 1, I have a power 1. Total power is 2. Total power is 2. X power 3, I have x power 2. I'll have a power 1 because 2 plus 1 is 3. If I have x power 1, I'll have a power 2 because 1 plus 2 is 3. And that is 3. X power 4, the power is 3 plus 1, 4. 2 plus 2, 4. 1 plus 3, 4. 4. That means every term should have in total, the power that's equivalent to the expansion. So x power 6 is right. This is x power 5. So I need a power 1. That's x power 4. I need a power 2. That's x power 3. I need a power 3. That's x power 2. I need a power 4. That's x power 1. I need a power 5. Good. If it is x plus a power 1, you have to come to a power 1. If it is x plus a power 2, you stop when you reach a power 2. If it is x plus a power 3, you stop when you reach a power 3. If it is x plus a power 4, you stop when you reach a power 4. So x plus a power 6, you stop when you reach a power 6. Up to this is easy. The problem comes here. Let's go back there. What is 2C1? Start with 2, write one number. Divide by 1 factorial. So do you agree this is 2C1? I'm recognizing a pattern. Remember, we can't keep on remembering formula. We have to recognize patterns. Let's look at 3. NC1 is N. So this 3 can be written as 3C1. That 4 can be written as 4C1. So this power 6, second term will be 6C1. You understand the pattern so far? Very good. Now, this is of course just 1. So I know that is 1, that is 1. So I'm not going to bother about that for the moment. I've got those coefficients. Let's come to 3. What is 3C2 equal to? 3C2 is 3C3 minus 2, which is 3C1, which is 3. If you don't like it, what is 3C2? Or start with 3, write 2 numbers, divide by 2 factorial. Still 3. So this 3 can be written as 3C2. Then is that 4C2? Okay. What is 4C2? Start with 4, write 2 numbers, divide by 2 factorial, which is 6. So that is 4C2. And this is 6C2. So by common sense, look, pattern 6C1, 6C2, must be 6C3, must be 6C4, must be 6C5, and that is 1. But I forgot, I think I did mention, but I didn't write it down. NC0 is 1. Why? Very interesting. NC0 is 1. Now, why is it? Very interesting fact there. What is NC0? Number of ways in which you pick nothing. 0 is nothing. Nothing from a set of n things without repetition. Picking 0 at a time without repetition. So these are number of things, n things. I put my hand, I pick nothing. I've done it once. If I do it again, I'm repeating. So NC0 is 1. Alright? So NC0 is 1. Look, NCn is NCn minus n, which is NC0. So NCn is also 1. So that is 6C6. You've got your expansion. So if you want to, indirectly, therefore, I've just shown you how we arrive at the general binomial theorem, which your teachers have taught you. So the only thing you have to remember is how to find NC1, NC2, NC3, NC4. There is, of course, some at GCSE level, you will have learned, some of you who are doing a bit of challenging work will have learned about Pascal's triangle, which can be the binomial coefficients. I don't want to use it. So if I have x plus a power n, I am using the pattern which I explained in those examples. If it is power n, it has to start with x power n. Okay? Then it will have x power n minus 1. Then it will have x power n minus 2. Then it will have x power n minus 3. So many terms. Then it will have x power n minus r. So many terms. Then it will have x squared. Then it will have x. Then it will have nothing. So powers, the expansion starts with the highest power and the powers of x go on decreasing. Total power must be n. This is n minus 1, a power 1. That is n minus 2, a power 2. That is n minus 3, a power 3. That is n minus r, a power r. That is squared, a power n minus 2. That is power 1, so a power n minus 1. It has to stop at a power n. Look, n to 1, there are n terms. I've got an extra. There will always be n plus 1 terms. The coefficients are very simple. They depend upon that. Power is 1, so NC1. That power is 2, so NC2. That power is 3, so NC3. That power is R, so NCR. That power is n minus 2, so NCn minus 2. That power is n minus 1, NCn minus 1. That power is n, NCn. That power is 0, NC0. Now, I had also taught you NC1 equals NCn minus 1. NC2 is NCn minus 2. NC3 is NCn minus 3. NC0 is NCn. In other words, we have deduced so many properties of a binomial expansion. This is the general binomial expansion. And please remember, this is the most important term. If it is a power 1, second term. A power 2, third term. A power 3, fourth term. So a power r, r plus 1th term. It is not the rth term, it is the r plus 1th term. Like a power n will be n plus 1th term. So instead of this is a formula you will find. You won't see NC0. You may not see NCn, but this is the general formula which you will find in your formula books or textbooks for x plus a power n. But I would prefer you use the properties. What are the properties to recollect? X plus a power n starts with x power n. and ends with a power n. The powers of x keep going down, the powers of a keep going up. The total power in any term should always be n. So if you have x power, so let's say you're doing x plus a power 10, you've got a term in x cube, then it has to be a power 7. And the coefficients depend upon the power of a. If it is a power 1, it will be nc1, a power 2, nc2, a power 3, nc3, and so on. So I don't want to write all that. It's all going to be in the handout. So I'll just use that principle to show you how I can how I can do an expansion. I think I have time enough to show one expansion. So it shouldn't take, let me take a very simple expansion. Expand and simplify root 2 plus root 2 plus 1 power 4. Easiest way, start with root 2 power 4, then root 2 power 3, then root 2 power 2, then root 2 power 1. Done. Next, total power must be 4. This is power 4, so that's 1. That is 1 squared, that is 1 cube, and 1 power 4. This is power 1, so 4c1, that is power 2, 4c2, that's power 3, 4c3, 4c4. So root 2 power 4 is 2 squared is 4, plus 4 times root 2 cube is root of 8, which is 2 root 2, plus 4c2 is 6, root 2 squared is 2, plus 4c3 is 4, root 2 plus 1. 1, 2, 3, 4, 5 times. Correct? So add the numbers 4 plus 12, 16, plus 1, 17, plus 4 to the 8, 8 plus 4, 12, root 2. I have shown you how to apply binomial theorem. In the next lesson, I'm going to take up a couple of more examples how to apply and how to find a particular term. Thank you very much. I'll see you in the next lesson. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.